All right, we're good to go. Great, thanks for spending your last session at NDC Oslo. Well, there's one more, I think, after this one, but selecting to spend that with me, that makes me delighted. So, my name is Jakob Ehn. I'm working at a company called Active Solution back in Stockholm, Sweden. This is the AI-enhanced version of myself. I usually prefer that nowadays when I get older. The AI just makes me somewhat nicer looking. So this talk will be about developing agents and copilots with Semantic Kernel. So there's been a lot of AI talks this conference, a lot of LLM talks. So this will not be a theoretical talk, how they work. This will not be like the moral, philosophical questions that surrounds them. Those are very important topics, and there's been some great sessions on those topics. But this will be more about how you actually build stuff on top of this, which is kind of cool because most of us are developers, right? So we can build things. And these models are really interesting to build applications on top of them. So we as a company, we have been working with the AI services for a long time, but what is now maybe referred to as traditional AI services. But it really has exploded with the generative AI stuff, obviously for the last 18 months or so since ChatGPT came out. So in terms of calling these things, assistants, copilots, agents, and so on, this kind of line is quite similar to what we have been doing for the last 18 months, going from left to right here. So what started really was that most companies wanted kind of their own ChatGPT because they really liked what they could do with it, but they don't want to have people use that service. They want to have control of everything, locking it down and so on. So we did some work in actually deploying ChatGPT similar services within the enterprises. So these are the chatbots that you associate with ChatGPT. The next step is what is called RAG, Retrieval Augmented Generation, which is a fancy word for how can you use this technology with your own data, because that's when it gets really interesting for enterprises. You want to use the reasoning capabilities, the analytical power within these models, but as an enterprise, it's not really interesting if you don't use it on your own data. So that was kind of the next step that we are still working on with a lot of customers, seeing how can we combine the models on their internal documents, internal services, and so on. And this are referred to as a RAG solution, where you actually retrieve some data and you augment that to the response from this large language model. And the next up is what is often referred to as a copilot, when in addition to just reading, fetching information and producing answers, you actually want to build systems that actually can assist you and actually do things on your behalf. And this term obviously is used a lot by Microsoft. And the idea is that this is an AI assistant that will kind of sit next to you. It's a copilot. It's not an autopilot. So it will help you on your daily work. So it will know your context, it knows what you're doing, and it tries to be smart and assistant. And you can build this in many ways, and I will show you some example how you can do that with Semantic Kernel. And then maybe not the last step, but the next step is when you take these copilots or these assistants and make them more or fully autonomous. And this is typically what is referred to as agents. When you combine all these things and let them be, for example, triggered by something that's happening, and they can be triggered by themselves, and they can do actions without actually any human intervention. So that can produce some really interesting scenarios. Obviously, this is a maturity thing. You can't start with that on that end. You really need to learn how this technology works, move from the left to the right here before you actually go into that direction. But I will show you an example at the end on kind of an agent-like scenario that you can also do with Semantic Kernel, when you have things pretty much running on their own, making decisions on their own, and can produce some interesting results at the end, hopefully. So Microsoft obviously has betted a lot on this. So I think this was from Ignite last year when Satya said that we are the Copilot company. So they went all in on this, and obviously AI is the hype nowadays. So they're betting hard on copilots, and you probably you haven't missed that, right? You've seen copilots pop up everywhere. So they're pretty much building this stuff into everything. You have the copilot, which is what's used to be the Bing search. That is the copilot. But then in addition, you have copilots in Windows, you have copilots in Office, you have it in Azure. You probably have it in Notepad soon as well, right? They're sticking copilots everywhere. And again, the idea is that this will be an assistant that will help you along the way. And some of these are pretty good. Some of them I don't think will see the full value yet. They're still pretty like not dumbed down, but they're starting slow, I think, and they will probably progress. But I think most of us can see the power with this type of tooling. So, okay, what do we mean by a CoPilot or a CoPilot application? So I usually try to explain this in a very simple way. So if we're building traditional applications, we have an application with some UI, and when the user wants to do something, the user browses to a page in a web page or to a desktop application, and he clicks some buttons. That will trigger some logic that we have implemented. We did some requirement, and we realized this is a user story, so we need to implement that, and maybe that thing talks to an API, for example. And then you want to implement another user story. That could be another user interface, another piece of logic, and so on. And maybe we need to fetch some data from a document store as well. But this is obviously a very simple example, but that's typically how we do when we're implementing applications. We're figuring out the requirements, we implement those requirements, and then the user can use the application as we intended it. But if you kind of switch this around and thinking more of this, like let the AI be the orchestrator, then it would be more look like this. So instead of building the UIs, obviously now we are starting to use more and more the chat interface. So we're kind of replacing the UIs with the chat interface. But what's interesting is that then we're letting the AI now actually be the decision maker, that what needs to be done to actually fulfill the request, answering the query or the instruction that I'm giving it. Well, then it's up to the AI to kind of reason about that, analyze my query, my wish, and figure out, okay, in order to do this, I need to call some services. But the AI can't do that on its own. It can't reach out and call our internal company service, for example, or talk to documents. So we need something in between there. And this is typically what we mean by a plugin. So in Semantic Kernel, you have plugins that will be the bridge between the AI and your data, your services. And that is really the key here, how you would implement these copilots. So I don't know how many have used the APIs from OpenAI or Azure OpenAI. So in one sense, this is like the simplest API ever. You pass it in a string and you get a string back. But if you actually have used this API, there's a lot of complexity around it. So first up, it's not just one model, right? The GPT models are progressing, and there's so many other models as well. So just having some kind of abstraction or thing in between here that will assist us to use those APIs over time is really helpful. And then you need to deal with things like the context, because context is super important with the language models. You need to pass it the right information in order to actually get a good response back. You need to think about history, the chat history. These language models are stateless, so they don't remember anything that you asked them before. So when you're using ChatGPT and you can do follow-up questions, that works because under the hood they actually pass the whole history back to the language model, and that needs to be done in every application that you're building as well. And you need to deal with things like hallucinations and all those problems that comes with the language models. And then we don't have any access to external data. Obviously, so the language models are, the GPT models are running in the cloud. They're stateless. They can't access anything. So you need to provide that somehow. And then you kind of have the problems with but that will be like my own native code, the code that I write. So we have LLMs and we have native code. So how can we actually, combine these things? That is the tricky part. And also with the large language models, I like this kind of quote that hard things, things that used to be really hard, can now be really easy with the language models because they can do really powerful things. Things that could take like weeks to implement before, you could do that in like 1 hour. But on the other hand, if you try to use the large language models for everything, really simple things can turn out to be really hard actually. So it's the hammer and the nail problem. You don't want to solve everything with a large language model because they're not good at everything. And the classical example here is the math that everybody keeps referring to, like these models are not good at math. But doing math calculations in computer programming is super simple. We've been doing that for 50 years. So again, use the language models for what it's good at, but not for everything. And then again, you need to combine this. So Semantic Kernel is an open source framework from Microsoft. So this is started out as like the core of their own CoPilot stack, and then they open sourced it. So initially, this was only for .NET. And if you have entered the AI space, you probably realize that there's a lot of Python out there. So for people like me from the traditional Microsoft space, we're a lot in .NET, so the Python world is a bit scary and takes a lot of time to just digest and go into. So having a proper .NET framework is actually really nice. Now they actually added also support for Python and Java as well, which actually turned GA back at the Build conference. So you can actually select all of this language. But for Python, there's also a lot of other frameworks like LangChain and Llama Index and so on. But if you're in the .NET space, the semantic kernel is the way to go. And again, it lets you combine then the language models with your own code. And we'll see a lot of examples on that. So this framework is extensible by you implementing plugins. That's what you'll be doing in terms of actually having it be able to access your own data and so on. So semantic kernel is all about the kernel, as they call it. That's the main object that you will instantiate, and you'll pass it various AI services, so it can speak to various AI models over there. So it's not just the GPT models; you can also hook it up to other models as well. You can host the GPT models in Azure or in OpenAI and so on, and it will kind of abstract a lot of the things away from you. And then it has a lot of functionality in order to actually create prompts. It has things like templatization support. It has obviously things like monitoring, telemetry, and so on. So it just makes it really easy for you to talk to these models. So I'll show you just how to get started, so you can know what it looks like. So I'll just show you some code snippets. So to do that, I'm going to use the notebook support in VS Code, which is really nice. If you haven't used it before, this is very common for in the Python world with the Jupyter notebooks, but it works really nice for .NET as well in VS Code. So let me just show you some examples on how easy it is to get started with semantic kernel. So let's just start by looking at the kernel. Well, first up, you need to start obviously with the NuGet package, this one. So Microsoft semantic kernel, that's a NuGet package you need to install. And then you need to create the kernel that I mentioned before, which we'll do here. So you create the kernel, and then you attach some or multiple AI services to it. So in this case, I'm using the Azure OpenAI. You can see in the commented out section that's how you would use the OpenAI API. Those APIs are very similar, but it's mainly around the authentication that is different. But you also have other options there. And then you build the kernel, and then you're good to go. So that's really all you need to do. So let's just run this code. And then we have the kernel. So now let's just do the most basic thing. Let's just run the prompt through it. And to do that, I will run this code. And I set up some settings. So there are some settings around these models, things like the temperature, which kind of controls how creative it should be, how static, how deterministic or non-deterministic it should be. You have things like max tokens, how many tokens should it return, because tokens is what you're paying for here. The amount of characters or tokens that you're passing in and retrieving, that's what you'll be paying for. So you want to make sure that you don't want to have it create a new novel if you don't ask for it. And then I'm just going to use the invoke prompt async to tell it to write a funny joke. And hopefully we'll get a funny joke in the end. And it says, why don't scientists trust atoms? Because they make up everything. I actually found a post yesterday, because even if I rerun this, I usually, in many cases, I do kind of get the same jokes over and over again. So I had to actually Google that yesterday, and it turns out that ChatGPT or the GPT models, they kind of prefer the same 25 jokes all the time, which is kind of interesting. But I guess it's like I don't remember more than 5 jokes at the most. But again, this is how easy it is. It's just once you have the kernel, it's just one line of code, and you can run it. So then you can do like more advanced things. So for example, you have things like templating support, because this is all about the prompts. So you heard a lot about prompt engineering, and you'll be spending a lot of time crafting these prompts. They can be like the make or break of a project. Actually, you want to get these prompts right. And so once you get them right, you probably want to parameterize them like this. So you can, this is just a simple example, obviously, but in this case, I can use the same prompt, but I can pass it in variables at runtime. So I'm having the same prompt, but now I can pass in the topic as the parameter. So in this case, I'll actually be running then 2 prompts. So now we get the first joke about food, and then the second joke about consultants. And again, these prompts now, you can store them in many ways, obviously. Now I just hard-coded the prompt, but typically you want to store them somewhere else. Because in many cases, when you're building applications on top of the models, the prompts are what you'll be changing a lot. So you want to have a simple way of changing them and having them applied in your applications, probably without rebuilding the whole application. So one powerful thing then, and also quite important, is the ability to actually combine multiple models in the same program. And this makes sense for many reasons. So in this case, I'm again using the same add Azure OpenAI, but I'm calling it twice. And I'm actually pointing to 2 different deployments. So the first one is 3.5 Turbo, and the other one is 4.0, the latest one. And why do I want to do this? Well, again, this really comes down to cost and performance, because the more powerful models are, they're more powerful, obviously, but they're also a lot more expensive, and they're typically slower as well. And for many cases, you don't need those models. Once you start breaking this down into smaller prompts, you can actually use the 3.5 models or even simpler models. They will work perfectly fine for many cases. And then I can run the same prompt, but I can ask it to use various models here. So in this case, I'm telling it to write a funny joke in 10 words. Each word should start with letter A, B, C, and so on. This was actually one of the things that when they announced GPT-4, this was one of the kind of samples that said, look at how much more powerful GPT-4 is. Because usually, I think 3.5 has become better since then. But usually the 3.5 model can be a little tricked out by this and doesn't always get the letters right and so on. But nowadays it kind of gets, usually gets it pretty much right. But you're supposed to do a joke with starts with A, B, C, and so on. And GPT-4 typically gets this a lot better than the 3.5 model. But again, the important thing is use the right model for the right task. And the general guidance from Microsoft is, start with a powerful model, make sure that it works as intended, and when it does, see if you can lower it, to save cost and to gain speed, but still, get the same quality in the output. And obviously, in many cases, you'll be building, chat-like interfaces, and so doing that with Semantic Kernel is also really easy. So, chat history, for example, this is a class on its own, because that's something you need to deal with. So you'll be creating a chat history, and then you can, implement a chatbot pretty much just like this, by just, asking the user for something, adding that message to the history, and then run the prompt, and then you take the reply from the assistant, from the model, and put that as well back in the history, and then you can use that in a loop. So if I run this, so this is kind of interesting. When you run this in a notebook and ask for input for the user, you get this up here. So it's a weird UI, but down here it says, hi, can I help you? And I say, I don't know. What can you do? And then, it's going to reply down here, and it's going to say something, and I can ask, something again. Bye. But again, like 10 lines of code, then you have like, the full chat experience with history, because this will now allow me to actually do follow-up questions, because I'm passing in the history all the time, but actually Semantic Kernel does that for me. So that was just a few examples on how easy it is to get started, and it's really nicely implemented. I'd say if you're building like an ASP.NET Core, you set it up as you would expect with dependency injection, everything. So it really nicely integrates with your application as a well-written .NET framework. I haven't used the Python and the Java versions, but they're also like 1.0 now, so they're similar feature support as the .NET version. Okay, so that was the basic stuff, having a framework that makes it easy to call the API, but that's not what you're here for. So in Semantic Kernel, they have the 3 Ps, which are like the core of building copilots and agents. So first up, you have plugins, planners, and personas. So plugins, this is the where you'll be writing your code. These are like, if you think about the AI as the brain, the plugins are like the hands and arms. They can actually do stuff because this is your code. So this is how you'll build the application. But the plugins can actually be either native, like your own code, or they can be prompts. As I showed you before, you can actually encapsulate prompts and reuse them. And I'll show you how that works. But if you're doing it native, this is how you will actually do things, in the real world. Actually, calling services and fetching data and so on. You'll do that through plugins. But then the interesting part is really the planners. So the planners is all about, figuring out what do I need to do in order to actually, reply or accomplish the request of the user. So the planner will see the query from the user. It will know what plugins exist, and it will figure out, okay, in order to do this, I need to call that plugin. Maybe I need to call that plugin, and so on, and then finally produce a result back. So this is like kind of where the magic, the AI orchestration, comes into place. So it will decide this on its own, what it needs to do. And possibly it will call one or two or multiple plugins. And finally, you have the personas, which is really often called like the system prompt or the meta prompt, which like in ChatGPT you don't really see it. It's hidden below, but you always have this when you talk to these models because you need to give it some kind of instructions on how it should behave. But you can also have things like the personality, what tone should it use? Should it be like sarcastic or should it be nice and friendly? You can also give it some grounding data to kind of trying to make sure that it answers only in a specific topic, and if it's not in that topic, it shouldn't reply at all. Those are the kind of things that you will add to the persona. Maybe things like if you don't know the answer, just say you don't know. Those kind of things is what you'll put in the persona. So let's just look at some examples of these plugins then. So a plugin can be either a prompt, and in that case, it will be like a YAML file, because YAML. And so there's some interesting parts here. First up, it's a template. This is the prompt itself. It's nothing super special about that. You can see that it's having a parameter as well, or a kind of a variable, the input. So in this case, it's a prompt that is supposed to create an excuse for a certain reason. You can also see that the template actually has an example in there. And that this is also a very common technique to actually include an example in this prompt. This will, in general, make the responses a lot better. So this is called like a few-shot or one-shot learning. Just by doing that, the responses will be much, much better and more deterministic, and actually the way you want to, if you give it an example of what you would expect. So that's a template. That will you'll be spending time crafting those templates. Next one is the description. And usually descriptions aren't that interesting or relevant, but in this case it's super relevant, because description, this is what the AI will use to decide if it should call this plugin or not. So you'll need to be very, very specific and detailed here to make sure that it knows when to call this plugin. So in this case, it says description is turn a scenario into a creative or humorous excuse to send your boss. That's the description of the plugin. And in this case, it also has a variable. So we'll have a description on that variable as well. So in this case, it's the event that an excuse needs to be generated for. Because the AI will call this plugin, and when it does, it also needs to pass some value for that variable. So it will look at these descriptions and figure out, should I call this or not? And if you don't do this right, it won't be called when you want it to be called, and that will just create very strange cases. And then you can store this YAML file. I mean, you can create this dynamically if you want to, or you can store this in a file, or in the code, or in a database, or anywhere, and can reuse them. And then you can also modify them and kind of reload them without rebuilding the application. But then you have native plugins. So this is a C# example of that, and this is also very, very simple. It's just a method in C# that you'll annotate with the kernel function attribute. That's how Semantic Kernel knows that this is a plugin. And then again, you have the description that I just showed you in the plugin. You have the same thing here. You have one on the method, and then you have another one on any parameters that method takes. So in this case, it's the square root method, so some kind of math plugin. And on the bottom half is how you actually import the plugin. So Once you define the plugins, you'll import them into the kernel. And once you do that, the kernel will be able to call that plugin if it finds that it needs to. This is the same kind of plugin in Python, by the way, if you're a Python developer. So, and Java is also very similar. Okay, so those are the plugins. And then by the planners. And so again, the reason or the goal of the planner is given a user prompt, create a plan on how to actually accomplish the request. And there's actually multiple planners in Semantic Kernel. So when they started out implementing the planners, they implemented kind of their own planners, where they're using the language models, obviously, to kind of build a plan. And a few of those exist still, like the HandlebarPlanner and the function stepwise planner. Those are completely built by Semantic Kernel. But the first one, which is the most common one, is called function calling. This is really based on, because while they were doing that, OpenAI released something called function calling, which is a thing that is built into the GPT models, which does this thing, right? And I will actually show this to you, because this is kind of important to understand how this works. So let me actually go to this page. I think I have it open here somewhere. So this is just the announcement post when they released this from OpenAI. This is back in June last year. And I'm just going to walk through the example here. So again, so the case here, or the sample here, is like, okay, so what's the weather like in Boston right now? That is a question to the API or the model, and obviously the model doesn't know what the weather is right now in Boston, right? If you would ask the model, it would probably say I don't know, or it would kind of hallucinate some kind of weird answer. But that's not what you want. You want to have the actual weather. So what actually happens now is a thing in 3 steps here. So let's just quickly walk through those steps so you all understand how this actually works then. So let's do this. So first up, what you would do is you make a call to the API, and you're passing 2 things here. So the first one is the message, which is, obviously, this is the message from the user. So we have the role user, and the content is what is the weather like in Boston. But that's not only what you're sending. You're also sending the list of functions here. So you're passing it the definition of a function. In this case, the function is called getCurrentWeather. It has a description, much like what we saw before. It has a parameter called the location. And so the thing is, you're telling the model that you're asking it a question, and you're also telling it, hey, I have some functions. So you're giving the model that knowledge. And then you let the model decide, should I call that function or not? Now we just have one function, but this could be many functions. And you're giving it to the model to see, okay, if you want to, you can call this function, right? Maybe it doesn't, decide that it needs to. But let's look at the response in this case, what the model actually replies with. So it replies back with, this is now from the assistant. And on the bottom here, you can see like the finish reason. That's why did the model stop and give you a reply? Usually that is just called had the value stop because it's done. But in this case, the finish reason is function calling, and it replies back with, hey, you should call. Or actually, I figured out that in order to answer your question, I would like to call the function that you have called getCurrentWeather, and you should pass it the value of Boston. So that was like what the model did now. It figured out that to answer the query, I need to actually call the function because that function seems to be able to give me the weather in the location, and I have a location in the query, Boston, right? So it did that kind of AI magic for us, but the model can't call that API, right? It can't do anything on the internet, and it's stateless. So it's actually asking us to call it. So that would then be step 2 in this process, actually call that API. So, and this could be now anything. So in this case, they're just showing it as a curl to some API. It doesn't really matter. This could now be anything. That's completely up to you. and the response in this case will typically be like, okay, in this case it replies back with some kind of weather information. It's 22 degrees unit Celsius, blah blah blah. Okay, but so now we have the weather in Boston in the API, but we haven't gotten a reply from the model, right? We asked it, what is the weather like? It hasn't replied yet. And the reason is obviously because it didn't know the weather. So now we need to do one more call back to the API. So let's take a look at that one. So now you can see we're actually passing it 3 messages. So again, we're passing it the first one because, again, it's stateless. It doesn't remember what I did last time. So I'm passing the initial question. Then I'm passing it the kind of response from my function. So I'm passing it now the knowledge about the weather in Boston. And also, again, like the function ones. And in this case, let's look at the response then. So now you can see first up that it says stop here. So it means that it's done. It actually could be that it would say you need to call another function now, depending on the case here. So this could actually go on now. But in this case, it realized that now I actually could reply back to the user. And it says the weather in Boston is currently sunny and has temperature of 22 degrees Celsius. So that was actually a 3-step process that you need to do to actually do this, the function calling. But this is now where the magic is. So the point is that these models now, the GPT models or the later versions, they are not trained, they are fine-tuned to do this. So they have become really, really good at, given a list of functions, pick the right function or functions and actually call them with the proper parameters and produce JSON back. And that is something that then the Semantic Kernel team decided that we obviously need to use this because this is now built into the model. So they did that by just implementing this in Semantic Kernel. So instead of doing all of that things that I just showed you, calling these 3 times, mapping between the JSON and your API, a lot of things needs to be done there. The only thing you need to do is that one. Just set one property and say, hey, call my functions if you find necessary. And it will do all of that for you. You don't need to do anything else. Then you can just invoke that prompt. And depending on what the AI will figure out, it will call one or more of your functions and produce the reply back to you. So again, it makes it really, really simple to use that. And this is the planner that you will be using most of the times. But there are other ones, as I mentioned. So there are some cases where the other planners can be interesting. One thing is around deterministic and potentially performance. So they have another planner called HandlebarPlanner, and the point of this one is that this planner can actually generate a full plan, and it will give it to you. And you can actually, if you want to, you can save that plan and store it, and you can reuse it later. So that will give you better performance, but it will also give you the kind of the option of actually evaluating the plan, right? Maybe you don't want it to kind of just go crazy and call your plugins without you knowing it. So using this kind of plan, you can actually store that plan. Maybe you could validate it, make sure that it looks good, and then you can reuse it later. So in that case, what you could do is you use that planner, and then you'll get the plan back as a string, and you can store that one. And if you look at that plan, it actually looks something like this. So this actually uses the handlebar language so they just selected that language to represent these plans. So you can kind of see here how that plan looks now. Like it identified 4 different steps, and one of the steps it actually kind of does a loop and so on. So again, you could kind of validate this and save it and use it later. But most of the times you'll be using the function calling. So let's just do a few quick examples of how that actually works. So let's take a look at the plugins. So let's just run that one. So let's just to show you how it works with a YAML prompt. So in this case, I'm just reading the prompt here, just from a file. That's the same prompt that I showed you on the slide before. And then the next step will be then to actually import that as a plugin. So you take that the definition, the YAML definition, and you import that into the kernel. And after that, it just becomes a plugin, like it would have been your own code. And then you can just run it. So in this case, what I'm doing here, I'm actually invoking that plugin explicitly down here. Because in some cases, you don't need a planner. You know what you want to do, so you can actually just call that prompt or call that function. Obviously, that would be a more deterministic way of doing it. So if I run this now, it will use that excuse prompt that I showed you before, so it will come up with an excuse. In this case, I'm passing it the input of customer meeting, so it should figure out why I was late to the customer meeting. So it says I'm running late for the customer meeting because I was being held ransom by giraffe gangsters who tied my shoelaces together with blah, 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 blah. But again, the point now is that looking at the prompt here that I showed you before, this is now stored separately. You can store this anywhere. You can load it dynamically, you can change it, and so on, without changing the application. And again, a lot of times this is what you'll be changing, not the application code, because the application code will be quite simple. It's the prompt that will change and be complicated. So that's the YAML part of a plugin. So let's take a look at the native one. And so in this case, I have a simple plugin that will call an API. So actually, in this case, it will talk to the Swedish radio API. So let's just take a look at how that plugin looks. So it's quite simple. It just has it's just one plugin, one method. So again, we have the kernel function up here, the attribute, and then we have the description. It says search episodes from the Swedish radio. Sveriges Radio inom parentes. And then we have the description, which is the search query. So again, given that I'm passing a prompt that has something to do with the Swedish radio, I'm asking about something, then probably I want to if I would use a planner, this is what it would use to actually call this one. And then I have some code in here that's not really relevant. It could be doing anything. In this case, it just fetches episodes from the Swedish radio API on a certain topics. So let's go back to this one and run it. So in this case, I'm passing it the query technique. So I want to have like tech-related episodes from the Swedish radio. So let's just run it to see that it works. And down here, so again, just getting the output from that plugin. So again, I'm not using planners now, just to be clear. I'm just invoking these plugins directly. And again, there are cases when you want to do that, when you don't need a planner. Because the planner is more, it will spend more tokens, you'll pay more for it, and in some cases you know what you want to do. You just want to run a prompt or a custom plugin. But again, like the interesting part really is when you are using planners, but now you kind of hopefully know how the plugins work. So let's take a look at how to combine these things and with a planner. So if you remember, the only thing I really need to do now, well, it's kind of two things. First up, I need to import my plugins. So in this case, I'm importing two plugins. First up, the one that I just showed you, the Swedish radio plugin. And then I'm also passing it another plugin, which is a file I/O plugin. So that's a plugin that can read and save files on the local disk. So I'm giving it two plugins. And again, the next part is this one. Oops. I'm saying that the tool call behavior should be auto-invoke. Again, that means that if the kernel now figures out that it thinks it should call a function, just do it. You don't need to kind of validate that with me. You don't have to do this. You can also say manual. Then you'll need to call it yourself. I'll show you an example of that later. But then I'll give it a prompt here. It says, get a list of all programs about technology that has been aired today on Swedish radio. List the programs with name, title, URL, and so on. Save the list of programs in a file called episodes.txt, and then return the list of programs back to the user. So again, this is like a query. That's something that I could say or write as a question. I'm not really referring anything to. I don't say exactly, about any plugins or. I'm just saying. I want to know what's on the Swedish radio today, right? And I want to save it in a file. So let's run this. See what happens. So I know that API sometimes is a little bit slow, so let's see how much time it is. So what actually happened now already is I can see now that we have a file down here called episode.txt. So I have a file. It was called episode.txt. So the planner figured out that I need to call that plugin because you asked me to. And it also responded back with the results, again, because I said, return the list of programs back to the user, so it did. So I actually used both of those plugins now, the Swedish radio plugin and the file plugin, and kind of combined them in the right order to do that. I didn't really tell it how to do that. I just told it what I wanted it to do. So just to show you what's going on, if I can run the same example, but just with some added logging. So what you can do is you can hook into a lot of things. For example, the function invoked. That's a way for you to you could do logging. This is also a way for you if you want to kind of override things, validate things before anything is being called. You can do that before it's invoked and stop it if you want to. In this case, I'm just logging out what's being called and what's being passed to the function. So if I'm running this again, it's the same prompt down here. But if we're looking at the results now, you can see, for example, that the first thing it did was to call the search episode function, and the query was technology, because that's part of something that I wrote in the prompt. It's really up to the AI to figure out what it actually needs to pass here. Sometimes it can actually tweak that thing, depending on how I describe the plugin. And then I get the same results again. So the next thing we would see here is actually another call to my file plugin, which has a function called write, and then it will pass me the path of episode of text and then the whole content. So that's pretty cool. It now can actually do things on my local laptop, but just by calling the plugins. The AI is still running in the cloud, right, in Azure OpenAI. That's where the GPT model is running. But it just stands for the analytical part, like the reasoning. It figures out what needs to be done, but I am actually doing the calling, running on my local machine now, which obviously is what you will be doing within your company. So just to show you that what I mentioned before, that what you can do also is that sometimes maybe you don't want to have this automatical invocation. So what you can do is actually, I don't need to run this, but and it's a little bit more code here, obviously. But what I'm doing here, I'm using just the enable kernel function, not the auto invoke. So I'm telling it to figure out the function I need to call, but don't call it on my behalf. And that means that instead I need to kind of loop through here. So there's some code here. It's not super interesting right now. There's examples on the documentation site. But the point is now I'm actually invoking this myself. I'm just running through the function calling it and calling them. And so what I can do here, obviously I can do a lot more validation. I can ask users for permission before doing things, because these plugins now can do anything. They could post stuff, create stuff, delete stuff, and in some cases you don't want that without the user actually clicking an approve button or something. But in other cases you do. So this is another way of doing that. You can actually call kind of the plugins yourself in a kind of generic way, but still having the model decide when it needs to be called. So if we're combining these things now, we kind of have our CoPilot, right? I haven't really looked at the system prompt. We'll be doing that to the persona. But we have the planners, we have the chat history, and we have the plugins. So if we combine these things, we can build, for example, a CoPilot application. So as an example of that, I built that kind of as a demo. It started out as a demo example internally, but now we're actually using it more and more because I also wanted to kind of show this to our customers so they can realize that what you can do with this technology, but with their own data. So I built like a CoPilot for my company, Active Solution, and I had it talking to our internal services. So we're a consultancy company, and obviously we have some systems that are our own. So we have things like time reporting, obviously, that's a third-party one. We have a system for resource planning, where we're planning our assignments. So say, hey, I'm working on that customer next Wednesday, on that customer next Thursday. That's information that we're working with a lot. We also have internal documents. We have a simple booking system for booking rooms and so on. So these are systems that we're using today, and they all have their own UIs. So I thought that this would be a good example of, let's build a CoPilot instead. Let's use a chat interface and have it talk to these systems. So let me show you what this looks like as an example. So we have our own CoPilot here. So this is copilot.activesolution.se. You can't reach it. Well, you can't log in, hopefully. Let's just switch to English. Okay, so, and again, it's kind of a demo application, so it has some, rough edges and so on. But it turned out to be, more and more useful, actually. So let me just do this. So just down here, then you can see it actually lists all the plugins that I added to it. So I have a few ones. This is the payment system, this is the planning system, the booking system, and so on. And we have some other stuff there. I also have one called math and one called time. Again, math, that comes back to the fact that you never want the language models to do math. So if I ask it to do some kind of summarization and so on, it shouldn't. It should call that plugin. Also, it doesn't know what time it is, right? The model has no idea what time it is right now. So, and a lot of these questions typically relate to, today or tomorrow and so on. So actually, to figure it out, it actually needs to fetch the time. So I think the first one I did, we have one called Shelly here. So Shelly is actually kind of a cloud API that you can hook up sensors to. So we have a few temperature sensors at the office that sense the temperature, and you can view a dashboard, but you can also use the API. So that was just the first one that I tried it. So let's just use that first as an example. So now what I can do, I can say, how hot is it at the office today? Like that. And let's see what it answers. So it answers back, okay, here are the current temperature at the office. So we have 4 of those sensors in 4 different rooms. So, typically one of them is a bit hotter, so it's 23.6. So it seems to be quite good weather back home in Stockholm. So again, it gave me the temperature there. And just can enable this little window that shows kind of under the hood what actually happened here. So in this case, I have a plugin called Shelly, and that one has 2 methods. So the first one will list all the sensors. The other one will give the temperature for a given sensor. That's all it knows that I have. So what it does is that it figures out, okay, first I need to figure out what sensors exist. So it calls that one. And then for each of those sensors, it calls it to get the temperature. Now, if I would have a function or a plugin that actually took a list in, it would call that one because it would be smarter. But in this case, I just have one, a method that accepts one of these sensors. And then I can see what it actually responded here. So for fun, then if I now say, what is the average temperature? What should it do then? Can someone suggest? Yeah. Exactly. That's what I want to do. I want to call the math plug. I don't want this now to just try to solve this math problem. It's not super complex, but it would probably not get it right. Another interesting part now is, so it needs to know the temperature. So do you think it's going to call the plugin again, the Shell plugin? And why not? Exactly. It also already has the temperature now in the history. So let's try this out, see what happens. So it's hopefully it's going to reply back with crash. That was weird. This has never crashed before. Okay, that's very strange. It actually gave me the right answer here. I'm not sure why it didn't reply. Okay, never mind. It actually did 2 calls to the math plugin. Well, first time, it didn't call the Shelly again because it already had numbers. It called the summarize method on the math plugin. So it passed the numbers, and that returns the number. And then it called divide because it needs to do the average, right? And for some reason, it crashed here. But either way, you can see the response here, so 22.275. Now, if I would have, let's do that query again, but clear in the chat and say, what's the average temperature at the office? Obviously now it's going to call the plugins again, because now I cleared the history, so it doesn't know anymore what the temperature is. So now, for some reason, now it replies back and says, the average temperature at the office is approximately 22.3 degrees. Okay, so that's a fun example, not really useful, but that was the first one that I did. So what's more interesting now is what I would typically want to know, okay, what's my plan for the week, for example? So if let's just ask that, what's my plan for the week? So now it's figuring out, I seem to be asking something about my resource planning, so I should probably call the resource system. the API, the active planning one, and now it replies back with the plan for me this week. So it says on Monday I worked on a Microsoft project. Tuesday I worked for a customer called Lania. Wednesday, Thursday, and Friday I'm assigned to the utbildning talare, which means I'm doing like speaker engagements. In this case, I'm at NDC Oslo. So this is my plan for the week. So it's fetching live data now about my plan. So it's actually starting to be more and more useful in the way, and I can also talk to this, use the microphone and just talk to it. It's quite interesting to see how it changes the behavior. But what's really interesting now, I think, is because we have UIs for this, right? We can go to this UI and fetch the information. But it's really interesting when you start combining these things in the same query. So let's do a kind of a more advanced one. So first one I can just say, like, because we also hooked it up to the booking system where all the rooms can be booked. So I just say show me all the rooms. Okay, so it's going to list. Okay, so it's going to list me all the rooms we have at the office and so on. So we have that as well. But now let's say if I do this then. Find or let's do it like this. Book a room at 5 p.m. that is large enough for everyone that works with Lania, one of our customers. So now it's like a multi-part query here because it needs to fetch information from multiple systems now to actually be able to do this. So let's see what it does. And you can never. There's no 100% guarantee that this works. So also always interesting with the demos. But I'm now using the latest GPT-4 model, the Omni one, which is actually really, really good, and also a lot faster than the old GPT-4. So let's see what it says. So first up, it lists the employees. We have 4 people at our company that works with this customer, Helene, Ivar, Johan, and Fredrik. So it says, so we need a room that can accommodate at least 4 people. Available rooms that meet the capacity requirement. So it lists then the rooms that is large enough for those 4 people. And then it asks me, okay, should I book this room? Yes, book Surfen. I don't think anybody needs that room today, that Friday at 5 p.m. And now it actually does, just to confirm, do you want to book the room? Yes. Okay. Maybe to understand, yeah. Okay, so now it's actually booked. You can see that actually called the book room method that in turn actually did a booking request for that room. And just to show you, if I quickly show you that plugin called Active Booking, just one detail here. Here we have that function that it called, and what I want to show you is the description here. It says book a room, and then I'm also saying here, always ask user for confirmation before calling this function. So you can kind of also combine like instructions and so on, because this will just be part of the big prompt here, and that is why it actually did that extra confirmation. Now, you probably, in some cases, you want to have that extra layer of security that I talked about before, maybe do a explicit approval by the user from your application, but you can also use like the prompt techniques to kind of steer it the right way, and in many cases, that could actually be enough. Sorry? Can we trust him that we always say them that way? No. No, you can't trust anything with the language models, to be honest. That is just the fact that it will not, and it's not deterministic also. So if there are things that you want to make sure 100% that it's correct or validate before you call it, you need to actually implement that yourself and not just trust the prompt. In like 99% of the cases, it will be fine, but maybe not every 100th. So that is the tricky part of trying to like steer the moving elephant on top. Like it's so powerful, but you have to kind of trying to control it. So let me just for the final thing. So that was kind of a CoPilot application. Again, this is now a separate application, but you can also see this being part of like those applications itself, like sidebars. So I could actually do like a sidebar to our own systems to have a chat interface and kind of build functionality that way. So some of the complexity around this will be that eventually, already I have quite a lot of plugins there, and there are some problems with that. The first one is that I'm passing a lot of information every time now. I'm passing all those function definitions every time to the model, saying I have this plugin, I have this plugin, that plugin. That will, take time, but most importantly, it will also cost me money actually. And also, it will be harder for the model to actually pick the right one. Sometimes these plugins will overlap a bit. Like we will have things like customer, for example, will appear in many of these plugins because all these systems referring to customers, for example, or project. And then it can be a little bit tricky. So if you're thinking more in an agent approach, what you'll be doing instead of kind of having like this big thing with a lot of plugins and trying to solve everything with the common system prompt, you can kind of think like you're breaking this up, kind of like a microservices analogy. Like you take the big system and break it down into smaller things. And that thing is often called as like an agent, which will typically be smaller and much more scoped to a specific task. So in this case, the persona will be really important because the persona will kind of define what the purpose and the behavior of that particular agent is. So you'll have, instead of having one big copilot, you'll have a lot of small copilots running around like small children. And then typically they want to talk to each other to actually solve the problem. And there are many patterns that you can do this, and this will be like a whole talk in itself, how you can build systems in an agent fashion. There's many approaches, and this is really like an area of active investigation and experimentation. This is not something we're doing yet with the customers, but it is like a really interesting area of research and like possibilities here, what you can do with it. So I just want to end with an example of how you can actually implement this with Semantic Kernel, because they are also working on that. And they're doing multiple kind of implementations of this. So I just want to show you one simple example, and hopefully you'll kind of get the idea then. So in this case, I'm setting up two agents. So let me just show you the code down here first. Here. So I have two agents. One is the software developer persona, and the other one is the conference organizer persona. And you can see when I'm creating it, I'm passing it like the instructions. That's the persona, the meta prompt. I'll show you that later. I'll give it a name, and I'll also give it a kernel. So again, the kernel could be different here. I could use different models for different agents. So once I have those two agents, then in this case, I will create a group chat with them. So I'm creating a group chat by adding these two agents. And then interestingly enough, I'm also having these settings, and as part of that settings, I have something called a termination strategy. Because the thing is, once I unleash these agents into the wild and they start talking to each other, when should they quit? What is like the end? When should they terminate? That's an interesting question and quite important to get right. So in this case, I'm actually passing it like my own implementation of that. So this is actually a class that is down here. So so this is a very simple implementation, but what it does in this case, it will just look at the last message and see if that message equals looks good to me. It should end. And the reason why that is really up to these prompts. So let's just take a quick look before I run this. So again, the purpose here is to write an abstract for this conference. That was like my demo example here. So the first one is, let's look at the software developer. So it says like, you're a software developer, you love to share your knowledge, blah, blah, blah. Your goal is to write and refine a proposal for the NDC Oslo developer conference. So the purpose of this agent is to write a proposal for a conference talk. And I'm giving it some kind of the structure it should use, some guidance. Also telling it that you will be getting like suggestions on how you can refine your idea. And it says it's only implement one suggested improvement at a time. So that's the developer persona. And then we have the conference organizer persona. So that will have another instruction here. So you're part of the team. Your goal is to actually evaluate sessions. I'm giving it some guidelines on how it should evaluate the proposal. It should be relevant. It should be clear. And I'm also giving it some kind of fake instructions here just to kind of prove the point. I'm telling it that proposal can't be longer than 100 words, and it has to contain the term AI overlords. And the reason is that because this will create a longer session here. Only suggest one required or suggested improvement at a time. So let's run this. and see what happens. That's good. Okay, so clear and .NET run. Again, you never know what's going to end up when you run these things, so that's also always interesting. So now I'm also starting this. I forgot to show you that, but I'm starting the conversation with like write a proposal with the following topic: developing AI agents with semantic kernel. That's my session now. So that kind of starting the conversation by that, and then I'm passing it to agents, and now they're going to start working here. So what should happen now is that the developer should pick this up and produce an abstract here. So it has an abstract, an outline, a lot of stuff here about semantic kernel and so on, key takeaways and so on. And okay, that was kind of depressing. Okay, let's try it again, because that wasn't good. It should be like a conversational session here, because typically it won't include things like AI overlords, and typically it's longer than 100 characters. Okay, so now it works a little bit better, I think. So okay, again, I get to the proposal here, and then the organizer now chips in and says that, okay, the proposal is clear, engaging, and relevant. However, it is longer than the 100-word limit. Please revise it to meet the word count requirement. So then the developer sees that and creates a new proposal. And then, let's see, the organizer says it's still beyond the 100-word abstract limit and does not mention AI overlords. Please include this term. Yeah, exactly, passive aggressive. And then it tries again, and let's see if it has AI overlords somewhere. Yep, here we have it, AI overlords. And yeah, maybe it's below 100 words, I'm not sure. But now it says, looks good to me. And that kind of terminates the session, and actually terminates this session as well, because I'm out of time. So thanks a lot for attending the session, and hopefully you'll be going home and building your own copilots. Thank you.